Hello friends, welcome to the ATC Double Cut. I'm glad to be back recording an episode. I have been busy with the usual travel, golf tournaments, research, writing, and I finally have some time today to record an ATC Double Cut. So let's do one that is timely, and it is related to soil testing. The first post that we'll talk about has a title, Recommended Soil Sampling Depth for Turfgrass. And I'll talk about a few other things that I recommend related to soil testing also. But this is a post that was written by request. Dr. Cale Bigelow sent me a message and he said he's hearing some different recommended sampling depths, maybe 3 inches, 6 inches, or 7.5 centimeters, 15 centimeters, 4 inches, or 10 centimeters. He'd been hearing different recommendations as the autumn soil sampling season comes up in the northern hemisphere. And he asked me, he knows that I recommend 10 centimeters or 4 inches, and he thought it might be good for me to resurface some of my previous posts about that. And I thought, you know what, let me just write a new one and give my current thoughts on this. So in August, I wrote this recommended soil sampling depth for turfgrass. As usual, I'm going to put a direct link to this post in the show notes so you can check it out and read it at your leisure. Look at the beautiful photo of some soil sampling tools set up at sunrise on a Tiff Eagle Ultra Dwarf Bermuda grass putting green in Thailand. So that was from one of my recent, well, not recent, maybe a year ago, soil sampling adventures. In the post, I wrote, I've been recommending a sampling depth of 10 centimeters or 4 inches for as long as I can remember. This is for soil nutrient analysis samples collected from turfgrass sites. Sometimes I hear recommendations from others for different depths. This is a reminder that I recommend 10 centimeters. So why do I recommend 10 centimeters? Because turf root zones for low cut turf generally don't go down to 6 or 7 inches. They don't go down to 15 or 18 centimeters. Those type of depths are related to agriculture, and they're related to soils that get plowed. And so when you're talking about depths of 6 or 7 or 8 inches, when we're talking about 15 to 20 centimeter sampling depths, that's what's typical for agricultural fields that get plowed. But turf does not get plowed. It does not. It's a no-till system, basically. We don't cultivate it by turning over the soil. There's no plow layer. And because of that, we don't really need to go that deep. And the roots are generally concentrated within the top 4 inches. Now, we hopefully will have some roots that are a little bit deeper. If we're growing Poa annua, or if we're growing Ultra Dwarf Bermuda grass, sometimes the roots will be a little bit shallower. So in that case, I look at the 10 centimeter depth as aspirational, because I have seen Ultra Dwarf Bermuda grass roots go to 10 centimeters or deeper. I have seen Poa annua at 10 centimeters or deeper. So let's consider these to be aspirational, and we can also have some of the soluble salts in the soil can rise up through capillary action. So even if our roots are only at 7 or 8 centimeters, the elements that are down at 9 or 10 centimeters, we can consider those to potentially move up. So I'm just really comfortable with a 10 centimeter depth. But there's another reason why I really like 10 centimeters. The reason, and that's related to math, because it's really convenient when we have a 10 centimeter depth because 1 square meter then is 100 liters in volume. And when we have 100 liters in volume, we can do a lot of mental math without having to think very much. So whether that is converting bulk density into the mass of the soil, whether it's doing some conversions of how much a certain amount of fertilizer applied is going to change the soil parts per million concentration of an element, or how much a certain amount of nutrient harvested is going to cause a depletion of that element in the soil. It's easy. It's really easy to do that type of math when we have a 10 centimeter depth, because 1 square meter of the root zone has a volume of 100 liters. We also have a lot of easy things that can be calculated with soil moisture, but that's not the point of this. We're talking about nutrients here, but just there's all kinds of benefits when we have a standard root zone. There's benefits in terms of easy mental math calculations when we deal with the root zones that is 10 centimeters deep. So I like that. It's also it's kind of a standard. Some other places in the world, I've mentioned before, New Zealand has a standard of 3 inches or 7.5 centimeters. So fine, if you're in New Zealand, do that sampling depth. But a lot of other places, they say, okay, 4 to 6 inches, or they say 10 to 15 centimeters. There's some variation in what you're allowed. I think we should just choose 10 unless we have a really good reason. 10 centimeters, 4 inches. We should choose that depth unless we have a really, really, really good reason to use something else. Another reason why it makes sense to use 10 centimeters, that's what the MLSN guidelines were developed using. That's what a lot of turfgrass research is done with 10 centimeter depth samples. My PhD research was done with 10 centimeter depth samples. So we've got all kinds of comparisons that can be made to other test results or to some soil test interpretation guidelines. We can make these recommendations, or we can make these comparisons by knowing that we've taken a sample from our site to a 10 centimeter depth. Now we can compare it to another database of samples that were also taken from a 10 centimeter depth. So that is the standard recommendation about depth. If you want to know if you've got a good reason, maybe you have enough confidence that you're certain that you have a good reason to sample at a different depth, that's fine. And if you don't have the confidence and you wonder if your reason might be a good reason, might be a good enough reason to sample at a 6 centimeter depth or a 3 centimeter depth or a 16 centimeter depth, please get in touch with me and ask. And I would be interested to hear what some of the other reasons are for why you wouldn't sample at a 10 centimeter depth. And you can ask me, and then I can say if I think that is a good reason or not. I have an extensive soil sampling instructions document, and there's a link to it in the web page here, in this blog post. It's a multi-page document. When I run that through a large language model, and specifically Notebook LM, and ask for an AI summary, this is what it returned when I said, please give me a 1-paragraph summary of the sampling instructions with a focus on the sampling depth. So that 1-paragraph summary, which I'll read here, goes like this. This document outlines ATC's comprehensive soil sampling instructions, primarily for turfgrass areas like golf courses, emphasizing precise methodology to ensure accurate analysis for fertilizer recommendations and monitoring changes over time. A critical aspect of these instructions is the sampling depth, which is generally recommended to be 10 centimeters or 4 inches. This depth is measured from the bottom of the grass and top of the soil or thatch, with grass and thatch intentionally left on the sample for standardized removal by machines at the lab. To analyze nutrient gradients by depth, especially for 1 out of every 5 greens, a specific protocol requires dividing the sample into 2 segments, a 0 to 5 centimeter or 0 to 2 inch depth segment, and a 5 to 10 centimeter or 2 to 4 inch depth segment. This layered sampling helps identify gradients in nutrients, pH, and salinity, and assess the impact of liming or acidifying treatments. The instructions stress the importance of maintaining an exact and consistent sampling depth for year-to-year comparisons to ensure reliable tracking of changes over time, and any non-standard depths must be discussed and clearly labeled. That is the recommendation. And let me talk for a moment about a couple of things. One is the sampling date. I think it's really important to sample every year, especially for sand-based root zones, because sand-based root zones can change quickly. Especially the longer your growing season is, the more biological activity there will be in the soil. The longer your growing season is, typically you're going to be applying more fertilizer. The grass is going to take up more nutrients. You have more chance for the nutrients to change either through addition or depletion, and you have more chances of pH changes. If you have a longer growing season, you may have more irrigation applied. If you're in the tropics, you have obviously a long growing season. Now you'll typically have a lot of precipitation as well. All of those things can lead to pH changes and nutrient changes. And I think it makes sense for, especially if you're on a sand root zone, test every year and test at the same time. By same time, I mean within the same 2-week period, roughly. And that makes sense to me. I'm surprised more places don't do it. And I guess it's just people get busy. Maybe I'm busy too. And one of the things that I want to implement, I want to recommend to all of ATC's current and former soil testing clients, I want to get something set up so I send automatic reminders and say, hey, I know you're busy, but we're coming up on the 1-year anniversary of your most recent soil test. Now would be a good time to test again. And the reason why I want to test within that 2-week window again and again and again, why we should repeatedly test, I would say that the change in nutrient levels in the soil over time could be more important than what the test results actually are in terms of is your potassium at 30 parts per million or is it at 50 parts per million? It's really hard to say whether if you're at 30 parts per million, what should you do? Or if you're at 50 parts per million, what should you do? It's really hard to say. When we did the MLSN project, we found the lowest value for potassium in the MLSN database under good performing turf was 4 parts per million, if I remember correctly. 4 parts per million potassium. So you can have good turf at 4 parts per million potassium. Now, that's extremely low, but you could have good turf. You could also have good turf at 7 parts per million potassium, at 10, at 15, at 30, at 50. So if we just test once and then try to check, well, what should we do? It's hard to say. I can just tell you are below normal. And compared to the MLSN minimum, you're below it or you're above it. Compared to the normal for putting greens, you're above it or you're below it. I can say that. But it's hard to say much more. It's hard to say you really should adjust the potassium that you're applying and apply more, or you can easily apply less. when we look at the change over time, when we test year after year at the same time and at the same sampling depth, now we can see how the soil potassium changed over time. So if you went from 50 parts per million last year and you test this year and you're at 30 parts per million, now we can say, wow, the system, so in this case, the system is the grass and the soil. We can say that the system lost 20 parts per million because it went from 50 to 30. So the amount that you applied, and that amount that's applied is the sum of what's applied through the irrigation water and the sum of what's applied through returned clippings and the sum of what's applied as fertilizer. That quantity of potassium caused or allowed the system, with the weather that you had over the past year, it allowed the system to go down by 20 parts per million. So now we know we're not applying enough. The system is losing potassium. So if we want to keep the potassium at the same level, we're going to need to apply more. Or if you notice that the potassium goes up, let's say it went from 50 last year and it's gone up to 64 parts per million this year, we know that the amount added is greater than the amount lost from the system. So as we look at that change over time, element by element, we can look at the phosphorus and the potassium and see how they're changing in the soil. And that change allows us to evaluate and then adjust the quantities of fertilizer applied. So that to me, that change over time is more important. I would say for most places, I'm going to call it more important. I was thinking maybe I should choose the word equally important, but I would rather see how things change over time. It is good to see what the level is, but I think we can make more calculated decisions and more accurate decisions about how we should adjust the nutrient supply by looking at how the nutrients change over time. I would typically say that we should test every 12 months. But if you're in it, let's just say, let's bring this down to budget and the standard of conditions. Let's say there's three things: budget, standard of conditions that you're trying to produce, and length of the growing season. So for places that have a longer growing season or are getting close to a tropical environment, for those kind of places, you may want to test every 6 months. You can see changes over a 12-month period may be larger than you would like, and you may like to adjust your nutrient inputs based on the changes that you can detect in only 6 months. But I'll tell you, in the tropics, when you get a lot of rain and a lot of growth in 6 months, that could be the equivalent of 2 or 3 growing seasons in a more temperate part of the world. So that's one place where you could consider testing every 6 months. If you have a very high budget, and let's say high budget is often going to go together with very high standards. So if you're trying to produce tournament conditions, or if you are a tournament level golf course, you're trying to produce really, really excellent conditions, then you may, let's link together. I think you understand what I mean about linking together. I mean, everybody's trying to produce really excellent conditions, but if you're the kind of place that just has, you got a few thousand extra dollars in your budget, and you're like, let's spend that on really checking the nutrients again. And let's go ahead and send out some staff to go collect the samples, and let's do the hassle of sending those samples to the laboratory in order to really fine tune what our nutrient levels are, how our soil pH is changing. for those kind of courses, it may be helpful to test every 6 months. So the two kinds of places where every 6 month testing could be fine are places that are tropical or close to tropical, just really long growing season, and places that have a big budget and really high standards, and perhaps those that like soil testing. And then, but for the usual place, for the typical type of property, I would recommend every 12 months. Now, the places that might test even more frequently, I would consider to be places with salinity problems. If you've got salinity, will kill the grass. If you don't manage it right, salinity can kill the grass. So in order to really figure out and get a real handle on what's going on with the salinity, you may want to test quarterly or even monthly until you are confident that you really know what's going on with the changes in salinity and what the effect of salinity through the irrigation water is doing to your soil. You may want to test more frequently than every 6 months. And if you're like a professional football stadium, professional baseball stadium, if you're doing professional sports, you may want to test monthly and monitor things a little bit more frequently because you've got a short season and zero margin for error. So that is my talk about sampling frequency. Let me discuss a little bit about the depth. I also recommend not only sampling to the 0 to 10 centimeter depth. For putting greens, I also want to do 20% of the samples, or 1 out of every 5 greens tested, tested at 0 to 5 centimeters and 5 to 10. Take a sample to the full depth and cut it halfway down. Cut it at the 2-inch depth, at the 5 centimeter depth. Now we'll analyze the top and the bottom separately. When we do that, we can check gradients in the soil. And because turfgrass is a no-till system, it's a system that gets a little bit of cultivation through core cultivation, through solid tine cultivation, sometimes through injection or banding of materials. That's the type of cultivation it gets, but it doesn't get plowed. It doesn't get turned over. And because the soil doesn't get turned over, you will often see a pH gradient. You'll usually see an organic matter gradient where the organic matter at the top of the root zone is different than the organic matter deeper in the root zone. You'll also sometimes see a pH gradient develop. And then when that pH gradient does exist and you want to change it, if you add lime to the surface, that is going to change the surface, but it's not going to change deeper in the root zone. It takes a while for that lime to work its way down. And so I find it useful to check what the gradients are in the soil. And to do that, I like to test 20% of the samples with soil samples that are actually divided by depth. That can be really useful, and I recommend that to you. Let's look at one other interesting thing. If you've been following along at all with the ATC YouTube channel, you'll have seen that in August, I went to Denmark and I worked for a week at the Danish Golf Championship, which was held at Footeso Golf Club, which is a pesticide-free golf course. Go to ATC's YouTube channel if you are at all interested in this, and I've got an entire playlist, which right now I think has 4 videos on it, and if all goes well, it's going to have 2 or 3 or 4 more videos on the topic where I give some commentary about this. I show what these pesticide-free golf courses look like. I show what the pesticide-free courses look like when a professional golf tournament is held there. I show dollar spot damage. And the best part is talking to the course managers who take care of these courses and who find a way to produce some really excellent conditions without using pesticides. I have a blog post about this with no videos. So the videos are on the ATC YouTube channel, but the blog post, which I will also put a direct link to in the show notes, has a title, A Pesticide-Free Golf Course. It's got a photo gallery in here with photos from the tournament week at Footiso. And let me do a little bit of a slideshow, and I'll go through these photos and just give a little bit of commentary. So if you are listening to this, I will describe to you, and I think you will hear through my voice and through my words, why it's just so interesting, so fascinating, and so surprising that we can observe these type of conditions on a golf course that hasn't received pesticides for 5 years and basically hasn't received pesticides for 15 years, but there was a 3-year period in which single applications of fungicides and herbicides were allowed to be made. I think, let me see. One fungicide, yeah. From about 2017 to 2019, one fungicide application, one herbicide application was allowed per year. So no pesticides at all for 15 years, except for those 3 fungicide applications and 3 herbicide applications, which were almost a decade ago. And this is no fungicides, no plant growth regulators, no herbicides, no insecticides. Wetting agents are allowed. So wetting agents, we're not calling a pesticide. Plant growth regulators, we are calling a pesticide. And these greens at Footiso Golf Club were superb. So I was there for the Danish Golf Championship. This is a DP World Tour event. And I'm showing a picture with 3 golf balls on a velvet bent and fine fescue green mown at 4 millimeters, and the surfaces were superb. The greens were cut at 4 millimeters. So 4 millimeters is something like 0.16 inches. And this is, it's higher than you'd typically cut creeping bent grass. It's higher than you'd typically cut ultra dwarf Bermuda grass. It's higher than you'd typically cut zoysia. It's higher than you'd typically cut Poa annua. But on these surfaces, the green speed with mowing at 4 millimeters with regular rolling, the green speed for the tournament days, I think the average was 10 feet 9 inches. I think that's what I measured. And I think it certainly was approaching 11 feet, which with the contour on those greens and with the firmness on those greens at Footiso Golf Club, that was perfectly appropriate for the tournament. There was a lot of extra rolling done this year in order to try to suppress dollar spot and to remove dew, because rolling has been shown to reduce dollar spot, and in the summertime, dollar spot can be a big problem. In the early autumn, dollar spot can be a big problem in this part of the world. And remember, they're applying 0 fungicides to control dollar spot. So they have to do things like dew removal and perhaps a little bit of extra nitrogen to try to stimulate growth in order to get the greens to be as good as possible. It was such a great venue for a golf tournament. The clubhouse at Footiso Golf Club is an old farmhouse. The maintenance yard, the greenkeeping shed, the greenkeeping yard is in old barns. And we had a great time there. There was a tent set up. We had some great pastries that were provided, great meals all through the week. It was really fun. And there's these beautiful thatched roofs. You might have seen from James Hempfling at the 2022 International Turfgrass Research Conference, which was held in Copenhagen. We took a trip to another golf course there, the Royal Copenhagen Golf Club. And one of the entrances to Royal Copenhagen Golf Club is right near some old homes that have beautiful thatched roofs. So James Hempfling took a photo and showed a picture of a thatched roof and made some type of pun about there being a thatch problem or something like that. Well, every day at Footiso Golf Club, we had a refrigerator full of Heineken Zero, alcohol-free lager, which was quite refreshing. We had wonderful food, and we had lovely weather that week, so we could sit outside and look at the thatched roof of this old farmhouse and barn that makes up the clubhouse and the maintenance facility there. So the greens at Footiso Golf Club, ideally they would be a base of velvet bentgrass, about 5% velvet bentgrass seed by weight, I believe, and 95% fescue if you were seeding. Or check the video with Thomas and see what he said. Maybe it's 1% velvet by weight and 99% fine fescue by weight. Ideally, it would be this base of fine. It looks like fine fescue, but if you look carefully, there's some velvet bent growing underneath. And Thomas has described how the velvet performs really well when it's managed like a fine fescue. And then those grasses, they blend together really well. What we could see, because there's natural grasslands that are unmown at the golf club, and there's a lot of bent grasses, coarser bent grasses, brown top bents or common bent grass, and creeping bent grass growing in those unmown areas. And they have seeds, and golfers hit their ball in there, and then they can get seed on their shoes, and then the seed can track onto the green. So we saw on some of the greens, and especially on the greens on the holes that had more of that unmown rough area, you can see some patches of coarser grasses, which are generally creeping bent grass. And we see really interesting differences between the patches of bent grass in terms of dollar spot symptoms. So I was really interested in how much dollar spot we would see on a tournament golf course with no pesticides applied for 5 years. I'm showing a picture on the screen now of a patch of bent grass on the 14th green that is completely free of dollar spot symptoms. And the next photo I show is the worst dollar spot that I saw on the course during tournament week. This is also on the 14th green. It's a different patch of bent grass, and this is a patch of bent grass that is obviously much more susceptible to dollar spot. And if we look at that one, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Let's say there's about 40. Let's say there's about $40 spot patches, or what are those called? Spots. A couple of them coalesced in this particular patch of or colony of creeping bent grass. So it's interesting to look at the different susceptibility between species and different susceptibility between different biotypes. There were people from all over the world, although most of the volunteers there were from Europe. And we stood on the 18th on the Sunday, and we held up flags and took a group photo. It was a wonderful crew to work with volunteers from Denmark, from other countries in Europe. And even the crew is international with people from Scotland and from Australia who now live and work in Denmark. There was definitely disease pressure. The Smith-Kearns model had, I think, 30 some days above the threshold value, or what's often used as a threshold value of 20%, leading up to the tournament. And during the tournament, there was a lot of dew in the mornings, and removing that dew was important in order to keep or in order to minimize the disease risk. The course just looked amazing. If you look at the pictures and if you look at the videos, I don't think you would have any idea that it's a pesticide-free golf course unless I announce it. And of course, I'm so astounded by that. I'm so impressed at the conditions. Yes, it's helped by the weather. There were timely rains because the fairways don't have irrigation either at this golf club. And so to have unirrigated fairways looking like they are irrigated, that you can give a lot of credit to the weather. But the tees and the greens are irrigated, and again, no pesticides applied. We have to give a lot of credit to the green keeping team for their careful attention to fundamental greenkeeping practices, and mowing the grass at the right height, applying the right amount of fertilizer, doing the right work at the right time in the right amounts. And that to me is just really impressive. It was pretty cool to see so many Baroness mowers. I see a lot of Baroness mowers, especially in Japan, but in some other places around the world. And there were Baroness greens mowers and Baroness fairway mowers used at the Danish Golf Championship. I brought my handy lens, my pocket loop that takes a 7x magnified picture, and looked at what the greens look like. On the final round of the championship, I share a picture that shows what looks like mostly fine fescue and a bit of bent grass in that image. And if you don't have one of these, you can go to the Pace Turf website and get a direct link. I definitely recommend the ones from Japan that I use. They're from the manufacturer is Vixen. You can order these. They cost a little bit more than the plastic ones, but these are made of metal. I definitely recommend them. There's some plastic ones that I see floating around that people get. I like the way these silver metal ones look, and they are from Vixen, and they basically you can get them shipped all over the world, and there's a link to that on the Pace Turf website. And I enjoyed a lot of early morning starts, and it was just a terrific week, and the conditions are superb. So I hope that you will, if you're just listening to this and this is your first time to hear about this, do go to the ATC website, check out a couple of the posts where I've shared pictures of just how good these surfaces look on a pesticide-free golf course. And also check out the videos, which you can see on ATC's YouTube channel. And you can see and hear from the greenkeepers about what they're doing, how they deal with knowing that your threshold for disease now is, it's there is no threshold. You're just going to get what you're going to get, and how you prepare for that, how you communicate about that, and how you deal with that, and what happens when you manage grass in that climate with no pesticides. I certainly learned a lot, and I agree with the greenkeepers there who told me that, you don't really learn until you're forced to. You don't learn until you're challenged like that. So there may be solutions out there, but they've been forced to find the solutions. And for people who don't get forced to find those solutions, maybe they're not learning that there are some solutions out there. So I don't know, maybe for other problems, if we if we can consider that maybe there's some solutions out there that would allow us to manage to produce some excellent surfaces with some alternative methods. I think it's really fascinating, and I'm sure many of you will think it's fascinating too. All right. Thank you so much for joining me on this episode of the ATC Double Cut. In the show notes, you'll find direct links to the posts that I mentioned and showed here in this episode. And I promise to be back again soon with more interesting turfgrass information. For now, I will sign off for ATC from Trong, Thailand. I'm Michael Woods. Bye-bye.